And this is a difficult thing to explain. Hear me out. The College Board doesn't test you on biomes per se. It's not like a bio class where you have to know the biomes as a thing to memorize. The College Board does discuss all environmental science within a biome. And a lot of times, you've got to know about that environment to understand the other stuff in that environment. So they might ask you a question about the tropical rainforest, and you have to know that soil is bad in tropical rainforest. Or they might ask you a question that happens in grasslands, and you would need to know that that's good soil quality. It's weird. All environmental science happens in some part of the environment, so it's always in one of the biomes. It's a pretty open-ended goal for you. So I try my best to just explain what it's like. For example, you had to copy this diagram where you have precipitation and latitude, like how much temperature and how much rainfall. And if you know the temperature and the rainfall, you kind of know what it feels like in each of the biomes. You may have seen this in your book that organized all the biomes kind of fall depending on high rainfall, lower rainfall, warmer temperatures, lower temperature, cooler temperatures. And theoretically, if you know the temperature and rainfall, then you can imagine how it feels there, so you know the adaptations that those species will have. And if you know why they're adapted to the environment, then you might know why humans care about that biome. This is always dodgy. I could talk about biomes for days and days because there's a lot to say, and the College Board might just ask you one of those details or something I didn't tell you. But you should definitely be familiar with all the biomes and how they are different from the other ones. I'm going to try my best to tell you what they might ask you. I don't know. Also, there's a little bit of mixed vocabulary. Please look up. You can break the planet into these bands based on latitude. So 0 degrees, 30, 60, 90. 90 is the poles. 0 is the equator. If you didn't know those numbers, you definitely do need to know that. Latitude starts from 0 to 90 north and 0 to 90 south. You know, like a 90-degree angle. And there's names for these bands. Around the equator, those are the tropics, northern tropical, southern tropical. That's also called equatorial regions. So these are the equatorial or tropical regions. These are called the temperate or mid-latitudes in the north and in the south. And this is the polar or arctic, polar or antarctic. And you kind of got to know all those. They're just regions of the planet. If you didn't know them, now you do. Yeah?
Are there more biomes than were on the pyramid?
So here's the crappy thing. You can call anything you want a biome. There's no like distinction of what really makes it a biome. So there's things called subbiomes or microbiomes. Like we've got oak woodland and coastal chaparral and coastal grassland and vernal pools, and like there's a bazillion little biomes. All you have to do is characterize it. I have about 12 terrestrial biomes in my slideshow. I don't know how many you got in your book. Do you remember?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, I got 2. Yeah, it's like 12.
You got 12? There are books that describe 6 major biomes.
So are these just like the big ones then?
These are like the main ones. And I'll tell you, there's a couple you can skip. Like, they're distinct but not ecologically that interesting. I'm going to just try to do the big stuff. And I'm going to start at the poles, and we're going to do tundra first. Please look up. Tundra is the dark blue stuff. Now check this out. I set at the pole, so there's the Arctic dark blue. But can anybody tell me why I've got dark blue here and dark blue there?
Because there's mountainous regions.
Those are called alpine tundra. So these have extremes of temperature because they're so far up in the earth. These are just from their altitude. They're called alpine tundra. There's two types of tundra, Arctic and alpine. Since we're going to travel from the poles down to the equator in this slideshow, we have to agree about how it's different in each of these parts of the world. And since it's all about temperature and rainfall, we kind of gotta talk seasons. Kyler, hit the lights while you're there and close that back. Thank you. Don't feel bad if you can't answer. Something like 20%, 23% or something of college graduates can explain why we have seasons. Ivy League science graduates, still right around half cannot explain why we have seasons. Like astrophysicists and biologists can't explain why we have them. So, I know it's pretty easy. You should know. It's just tough to get the words right. Anybody know why we have seasons? Why is it hot in summer?
Because the Earth is like kind of rotated like 20 degrees or something, so then the sun is more direct during different times of the year.
What do you mean by more direct?
Like a more direct, like if the north is kind of like slanted towards the sun, then it's just the angle kind of makes the sunlight more direct.
It was so good except for the direct part. Might have been thinking the right thing, but you might think the wrong one, so I can't tell. What?
I think like the Earth is like tilted on
Rather than
its axis a little
yeah.
bit, so when it like spins, it's like closer to the sun in certain seasons and further from the sun in other seasons.
This is a fascinating fact. We are technically closer during the winter.
Really?
It's not the distance.
It's not the distance.
But you know, it's, like everybody goes, yeah, I knew that, but they don't say it right, so I'm just testing. Anybody else want to give it a shot?
Isn't it like the angle that it hits it? The sunlight hits it, so
Is that what you meant by direct?
does it like
Yeah.
flip?
No. Anybody else? I wish our room was darker.
Oh,
It's
wait.
really.
When it orbits the sun, right? It's. I'm trying to think. I'm looking at the diagram of the planets. So.
Hey, will you do this to all four things? Thanks. If you do it two-handed, it goes faster. Okay, well, honestly, this is one of those, like, we're just going to take an aside so that we can all get on the same page, because this is an important thing to know about your planet, but does everybody know what all these parts are? The moon, the earth, and the sun. Good? Moon, earth, sun. And let there be light. If you can't see, you probably want to move. It'll just be 6 minutes. Okay. we live on this one. This is Earth. And I don't know how well you can see this from where you are. But just like there's a sunny side and a dark side of the moon, there's also a sunny side and a dark side of the Earth. At any given time, one half of the planet gets sunlight and the other half gets darkness. Done. Because it's a sphere, light can only hit one half, easy peasy. Now we call that a day because the Earth made one rotation around its axis. When this one makes it around, that's 28 days. It's a lunar cycle. Also a woman cycle, by the way, which I think is kind of fascinating. So we go all the way around the sun and get back. Whoop. That was 1 year. One lap around the sun. Then it goes this way. Oh God. The sun's about to go out. We got all our facts straight about days and weeks and months and years. Now, many of you mentioned the angle of the sun. And you're right, it is tipped, and you're right, it's about 20 something. It's 23 and a half right now. Fun fact, that actually varies a little bit. Nobody knows why. Our solar system has all sorts of weird irregularities. If you add them all up, it explains the majority of climate change. So ice ages and interglacial periods are caused by those irregularities, like the angle changing and stuff. But here comes an interesting part. Which direction is the North Pole pointing right now?
Towards the sun.
Yeah, make your arm the axis of the Earth. Okay, and if you look around, you see that everybody's pretty much got that. Now watch this. Keep your arm that way. 6 months later, which direction is that axis pointing?
Same.
It's same. Watch. 3 months later, it's the same. What a cool model. That it's always, that's actually kind of a neat mechanism in there. See how it's pointing that way? The whole time. All the way around the annual orbital plane, you can take a 365-day tour of the solar system. It's always pointing that way. Which means, if you're riding the Earth in the top half, you've got a few months. Oh no! Oh God! Oh, baby Jesus, don't! No! Say it ain't so! Okay. Oh, good God. End of days. I didn't apologize to that one lady. Okay, look. If you were on the North Pole here, you could have like 4 weeks of daytime and never get sunlight. See that? Like if you stick a little human right there, they're going to be in the shade half for 28 days straight. The only good vampire movie ever made, 28 Days of Night. Highly recommend. All of that spinning. And then, imagine 6 months later, if you're hanging out up here, you can just like wait a day and there's no sunlight. Look, this guy's still in the sun. Still in the sun. I mean, he's in the shade of that little knob, but he's still in the sun all the way around. 28 days. And then about 1/3 of the landmass of Alaska is in that circle of nonstop sunlight. But even if you're just south of that, it's still, you know, you'll get like sunrise is like, hey, look, there's the sun, and it'll just go psych, and it goes right back under, and you're like, oh man, we got 2 minutes of sun.
I had a friend from Alaska, and he said it'd be sunny just like all day, all night for like weeks.
Yeah. My oldest friend, she was a butcher and chef at a hunting camp, and she would just go up there for the sunny time, you know. And she'd say it was kind of gnarly because like it'll be 11 p.m. and like sunglasses bright, and then like it starts to get kind of dusky at like 2 in the morning, and then like you're like, oh thank God, it's almost sunset, and it's like psych, and it goes right back to being sunrise. This is weird. You see, if you were Mr. Alaska, you've got like a whole bunch of the year where there's barely any shade. Here you're getting 12 hours of daytime, 12 hours of nighttime. That's called spring and fall. In between the equinoxes, equinox, the day is the same as the night, equals the night, equinox. And then you've got like 28 days in the dark. That's when the vampires come out. That's scary. But this affects everything. If I could, you're right that sunlight might be more direct at a time, but the directness doesn't really change the temperature nearly as much as the net amount, the duration of the day. You see, like right here, the Earth is 3/4 of a rotation sunlight. That's like 18-hour day length. When you get down here, it's only half the planet. That's 12 hours. That's the equator, equal. Every day is 12 hours every day. But as you get more and more polar, you get more and more of the Earth's rotation in the sunlight until you hit that ring where it's 24 hours of sunlight. And the hours of sunlight is why we have seasons. Because children, what is the source of the Earth's heat? No. It's not the core either. Common mistake. You all know what you meant, but you said the wrong thing.
The time we are like in front of the sun.
What's that?
Like the time the sun's like hitting the earth.
Yeah, but the heat of the sun is not. Remember that heat is low
Duration
quality
of
energy.
time, not the temperature, but like
The what?
the UV rays.
Yeah, exactly.
What?
See, watch. Let me break this down. This is an important distinction, and then we're going to shift gears, okay? There's a reason I do this. All this comes up later. If you didn't know any of these words, you definitely wanted to scribble some notes. You all realize that the sun is hotter than F, right? Like, it's very, very, very hot. But do you also realize that if you shoot a human into space, and that human is halfway to the sun, what's the temperature of that human?
Too hot.
Nope, it is 207 degrees below zero.
Oh, what?
Because you gotta get really close to the sun before you feel its heat. And then you get a little closer and then it's too hot and you evaporate, yeah. It gets way too hot when you're at this. But heat doesn't travel very far. Remember how close you have to get to a human to feel their body heat? Heat doesn't travel.
Light.
Light does.
Does heat travel with the light?
Nope.
No.
Well, then how do we have heat here?
How do we have heat here?
I
You guys are
want
making
heat
some
here.
really good steps. This is good.
Atmosphere?
No. Silly. Yeah, a little bit. Who's tried the white t-shirt, black t-shirt in the sun thing?
Yeah.
Which one makes you warmer in the sun?
Black.
Everybody knew that. What is the source of the Earth's heat?
Absorbing the rays,
And then
transferring it.
to...
Wait,
Do you all understand how to explain the colors? White means no light is absorbed, all light is reflected. Agreed?
Mm-hmm.
And black is the absence of light. None is reflected. Black is the same color as nighttime because there's no light. So a black shirt absorbs all those rays. None are reflected. Agreed?
Yeah.
So if you absorb more light, you radiate more heat. Black t-shirt hotter in the sun than white t-shirt. Are we all on the same page with this? So now watch. We have seasons, because angle of the dangle, amount of sunlight, more sunlight absorbed means more heat radiated. Right? It's like if you leave the black t-shirt out in the sun longer, you'll be hotter. So there you go. More sunlight hitting you for more parts of the day, more of that rotation. See, that's almost a whole rotation around that circle. means you're going to be absorbing light and giving off heat for almost the entire day. That's going to build up a lot of heat there. That's the seasons. Longer days, more heat made by the earth. The source of the earth's heat is the earth. Like if you're wearing a black t-shirt, it makes you hot when you go in the sun because the black t-shirt. The sun's no different. You put on a white shirt, it's not like the sun changed. So the amount of heat reaching you from the sun would be the same, but the amount of converting the light is different. So it's about the conversion of light to heat. Sorry, the light to heat. Yeah. Heat gain is in direct proportion to the day length. That's why wherever you are on the planet, days are longer in summer and it is hotter in summer. Yeah.
Isn't it still cold though in places like Alaska, even when they do have the?
It's pretty toasty. So like if you're in a hunting camp in Alaska, you know you're probably wearing a t-shirt in that summer. But there is still a lot of chill. There's a lot of like currents and specific heat capacity of water. So how close you are to water and what percentage of your atmosphere goes over water. So like the land masses that are most contiguous around the planet have the most latent air heat because they're not losing all their heat to water. But if you're surrounded by water on your band, then specific capacity of water, so all the atmospheric heat becomes water cold. So yeah, there are still some other details, but a hot day in Alaska is a hot day anywhere. All right. Now we get to do some biomes because we got our seasons. Anybody want to ask me anything about it? Cool little model, right? Like how it does the little rotations, it always points the same way? Oh! P.S. Here's something else that it does. Um, 12 inches in summer. 10 inches in winter. It's got this little thing. So we are actually closer in the winter. All right.
How much was that?
It's like $180, I think. Yeah.
Does the Earth also orbit around the sun in an elliptical shape? What does that do?
It does have an impact on how much light reaches us, but the funny thing about light is it travels really, really, really far.
Mm-hmm.
So adding a teeny percentage of space dust in one season and not in the other does affect the strength of solar radiation hitting the Earth, but it's really minimal. So the amount of light given distance and shape is really subtle. Here we go. We're in the blue. Look at those seasons. Do you all know that like in Iceland and stuff, they have special ultraviolet light bulbs when you go grocery shopping? Like the bars are not dark. Like when you go to bars in Iceland, it's like super bright so that people won't get seasonal affective disorder, which is acronym SAD. Apparently in the winters, homicide rate and suicide rate go through the roof. So you gotta find a way to trick people into thinking that there's like a reason to be alive because our bodies are like, I'm just gonna hibernate. And you like gotta go to work when your body wants to hibernate, so you get all grumpy and pissed. It's like, I just wanna go to sleep. And you know, like teach high school kids or whatever. So they give you these wacky lights so that your body's like, oh, okay, I guess I'm outside. Isn't that hard? So you gotta trick your body to thinking it's getting sunlight. Like tanning bed lights. All right. Look. Imagine when it's been dark for 28 days and you get that first little glimmer of sunlight and then it goes away. And then the next day you get a slightly longer glimmer of sunlight and then it goes away. And then the third day of sunlight, it's like, wow, that was like 15 minutes. How nice. During that shutdown, when it was 28 days without any sunlight, what plant could possibly survive? It's like 70 degrees below zero and pitch dark for a month. So you have to have this in your notes. No productivity.
0?
Zero productivity in the winter. Like, the only energy transactions in life are stored energy. Like, you could eat potatoes and there's mice under the snow that are eating seeds. But there is zero ecosystem productivity in the winter. Of course, that also means, look at that summer. There's going to be 28 days when the sun doesn't set, so plants are just growing. You know, 28 times 24 is a big number. It's like 750 straight hours of sunlight. So that's like 2 months of our summer. So in 28 days, plants grow like a full season. That summer is a burst of productivity, nonstop. We call that extreme seasonality. Because the growing season is non-stop growing, and then the dying season is total everything dying. Because of that, you get hibernation, you get dormancy, plants. They all go seed to seed in like 6 months or less. Like, seed will sprout, the plant will grow, it'll make a flower, the flower will get pollinated, the flower will close up, and then it'll become a hard nugget of seeds, and then those seeds will fall on the ground and get kind of buried under mulch in 6 months. And since nothing can live there during the downtime, that also means that when you show up in the good times, there's no competition. So this is the heart of migration. It's really good when it's good because nobody could survive when it was bad. Imagine the sun hits, the snow starts to melt, all the rivers start to run, all the seeds start to sprout, and there is nothing there. A few mice that lived in caves under the snow, pretty much.
There's not an elk or a deer or anything
Yeah, you know, there's a few land mammals that had to leave.
for the winter?
So they all went south in the winter, right? And then it's like north and things are warming up, so then they all rush in and like, holy crap, now imagine being that first elk that gets to run into like that. Or like come over the pass and you're like, oh, there's like green grass and nothing else. Or being like the first duck that got confused and just like landed there and was like, earn my gurn, and there's just like non-stop feeding. They like fly back south and they're like, you guys, you won't believe. And they're all like greasy and like blubbery and like their feathers are all shiny and sexy. So they had a whole bunch of little ducklings. And now there's all these migratory birds because migration makes sense. Because if you can show up when it's good and then leave when it's bad. Do you understand that concept about like surfing, the endless summer idea? You've seen the movie Endless Summer?
Yeah.
Where you like chase summer conditions by globe-trotting around the planet. Like you get it. So because the seasons are so predictable due to sunlight and rotation and angle and the dangle and stuff, there's birds that are like just chasing the same weather band all around the planet.
The red knots are.
Yeah, among others.
But don't they lay their eggs when it's bad? So it gets better.
Yeah, so they got to get there early so that when the hatchling comes out,
It's nice.
they can feed it during the glory time and fatten it fast enough for it to fly away in a few months. Like, imagine that. Like if you ate whatever those little white flowers are, there's just like nobody else there. Migrations are trying to find these good times And BT dubs, the same productivity happens in the ocean, so ocean life migrates too. I wanted to name my son Gray because he was born during the gray whale migration. Because where we are, gray whales leave in the winter, go have their babies in Baja, nice place to spend the winter, trust me. And then when Baja starts to get hot and sticky, then they bail, and so February they come through here. My son was born at the peak of the gray whale migration. They come through here February 12th, my son's birthday, because by late March they're already up in the Arctic when the days are starting to get really, really long and all the stuff blooms in the ocean, and they just filter feed like crazy for 2 months and get all fat and blubbery, and then they go have like blubbery nookie down in Mexico and raise little blubbery babies during the winter and then go back home. So we got the extreme seasons, we got the shutdown, like boom and bust productivity, like going off productivity and then no productivity, boom and bust productivity. We got that dormancy, the hibernation, the migration. And the only thing humans have done here is change the climate. We don't like to live there. We don't have houses there. We don't have roads. We don't cut down stuff or drill stuff out of the ground. We don't really go up there. It's just too crappy for the humans. So other than heating it up, we haven't really impacted the habitat. Next, if we start heading south a little bit, we get to this place called the boreal forest. It is AKA taiga, like this. Taiga. That's the mid-colored green. If you look up at the map on the screen, the mid-colored green. So that's Siberia, Canada.
Montana.
What's that?
Montana.
Yeah, Montana. That mid-colored green. And here's the deal, if you imagine the weather, you've got sunlight all the time. These are extreme seasons, but there's always sunlight. So even in the winter, a plant can survive. It's cold and crappy, but there's still light. So with year-round productivity, now you've got resident wildlife. And you've got trees, these special trees. The average day, their light comes from the side. So they compete by growing upward. Anybody know the humidity when it's really cold? Like when you go to Mammoth, what happens to your nose?
Dries out.
Yeah, you get dry nose because it's like 0% humidity. When it's cold, there's no water vapor. All the water exists as frozen form, as ice. So when it's really cold, you dry out. What happens if you have big fan-shaped leaves, like a maple, and it gets really dry? What happens to all the water of the tree? Surface area, you lose all that water. So conifers have needles to avoid drying out.
That'd be the same for like a pine tree then?
It's conifer.
How do you spell that?
Conifer? C-O-N-I-F-E-R. Con-if-er. So look at these adaptations. Strong seasons, but there's always sunlight, so you can be a tree. You got to grow really, really tall to make sure that you're always getting some amount of sunlight. So they compete vertically. There's a lot of water around, so they soak it all up in the summer, and then they got to survive on all that in the winter without losing it to the environment. So you have spongy, soft wood, and you have needles to avoid drying out. Hey, can anybody imagine why you might want trees that are perfectly straight and really spongy so the wood is light? What's good about a perfectly straight tree made of really soft wood? That's right. This is what your house is built of. This is our logging country. Everybody thinks we log the rainforest for the trees. That is incorrect.
For rubber, right?
Oh, you know, tropical rainforest has very little usable lumber.
Not
So we
rubber,
did some
rubber,
rubber
it's
logging
rubber,
back
rubber.
in like the 20s and 30s or something, but we started farming them before World War II.
Rubber?
Rubber trees, yeah. Yeah, in the tropics, we cut down the trees because they're standing in the way of a place that we could graze cattle or try to grow some crappy food. Logging is almost no tree value in the tropics. Here's where our trees come from. Please look up. That is a lot of lumber. See how the light is coming sideways? Can you all see that in this photo? Sideways light? So they compete by growing vertically. The bottom of the forest is pretty dark. There's no leaves on the trees at the bottom because they're all trying to find the light. But then in the winter, they got to find a way to keep their water when everything's 0% humidity outside. So they have those needles. In summer, when there's water everywhere, they just grow. And they're still long summers, so this is really productive. These are really productive systems in the summer. Then in the winter, it pretty much shuts down, just a teeny little bit of sunlight. With all that water, these trees grow fast. So you can imagine, this is really good logging country. Your house is built of this wood. We use mostly Canada and the Pacific Northwest lumber. Eurasia uses whatever that is over there. And here, look, we use that wood, like through here. They use that wood. They use that wood. They don't build with wood. Some parts here you get a little wood out of there. Some parts here you get a little wood out of there, and that's about it. We got our softwood, fast-growing, straight. And you should know that this is a deeply impacted ecosystem. Because we go there to cut down the trees, this is a deeply impacted system. Maybe 20%, maybe less, is still intact. Next, we move a little bit further south. We're getting into the temperate deciduous forest. I think your book might have called this mid-latitude coastal forest or something. Is that right? Mid-latitude deciduous?
They call it deciduous.
Deciduous? Yeah. Check it out. It's like mint chip green. Which parts of the world have mint chip green? Europe and East Coast of the U.S. And anybody else see another area that has that mint chip green?
Australia.
New Zealand.
Pretty much where all the humans are. This is like the P.S. Since we're celebrating Indigenous Peoples Day today, previously known as Christopher Columbus Day, I should point out, look at how lucky the Europeans were to land in a place that has the same climate. They could grow the same trees, they could hunt the same game. They could wear the same clothes, have the same seasons. Didn't work out too well. Europeans were very uncomfortable when they went to the tropics, to Brazil, to Africa, to India. Europeans tried all over, but where they really set roots was when they could stay in their native biome. See?
What about the Roman Empire and the temperate trade lines?
So, coastal exception, but Europe was still pretty much temperate deciduous, and generally temperate zones are where humans thrive. So the Mediterranean is a blip of temperate landscape, but all temperate landscapes humans do well. Humans suffer in the tropics and we suffer in the poles. We're kind of evolved for the temperate regions. I mean, doesn't that look nice? You're programmed for this. We are built for this. Now, this explanation has a lot of words. If you just scribble a few, I think you can make sense of it. With 9 months of good season for growth, and maybe 2-3 months of actual winter, trees spend almost the whole year growing, and then they just take a quick little break. They take that quick little break when it's too cold to keep your leaves, so they just drop them. Anybody know what season the leaves fall? Creative thing about our language. So you make these big old leaves, collect a bunch of sunlight, and then when it gets too dry and cold to keep those leaves, you just suck out all the green so you can see the underlying color. Leaves change color because they were always that color. We just removed the paint off the top. And then those leaves fall to the ground, make a convenient little mulch to insulate the soil from the snow. Tree survives without leaves for a month or two, and then they make new leaves. It's called being deciduous. The word is spelled up there toward the bottom of the slide, deciduous. And these trees have a different shape. Instead of competing upward, they compete outwards. Because the sunlight is more direct here, trees have a different shape. They grow out. And if you've ever tried holding a jug of water at arm's length, anybody ever tried that? It's difficult, right? It gets really heavy really fast. So these trees have hard wood. Growing out, you can't do that with soft, spongy wood. And all that water weight of those leaves, that's really heavy. So trees that grow out like that, they have one of these trees. I mean, occasionally you'll find a few, but it's not like an industry of nice straight wood. So we make violins and desks and stuff out of hardwood.
Floors? Wait,
What?
aren't floors too?
Yeah, hardwood floors. Yeah, little pieces all smashed together. If you ever look at hardwood floors, they're like little lumps glued together because these are curvy little trees, so you got to cut into little rounds before you can slice it. Check it out. This looks like a nice place to be because humans are temperate species. Like your body feels good here because you're kind of evolved for this. Humans came out of the tropics, but after we evolved, we left the tropics pretty fast. We are suited best for temperate regions. That's why this looks like a good feeling. Every one of these photos, like, doesn't this make you want to feel like you want to relax? Like, I could chill there, Look at this one. I could like sling a hammock and sip on some chocolate or what have you. I could have a smoothie and relax. I could watch Netflix and chill there. That short little winter, you know, leaves come off, and then the rest of the time is just go time. So these are hardwoods, and this is probably one of the most impacted because we like it there. Almost all these places speak English, go figure. Modern society has debatably been a chase of this biome. There's a teeny little biome, almost nothing to know. This goes in 3 or 4 minutes. Please look up. In the temperate region of the world, so between 30 and 60 degrees, there is a little bit of rainforest. Please look up. Like you see the Pacific Northwest right there in this in the screen? The Pacific Northwest. You all recognize where Washington and Oregon are? British Columbia? Everybody knows this, right? North of California on the coast. And then can you all see Japan? You all know where Japan is? That like skinny 2 islands.
Yeah. Off of those.
Like on the side of Asia.
Yeah.
So those are the temperate rainforest. There's also a little bit on the Gold Coast of Australia, like from Sydney north. You see it on the edge down there? This is where ocean storm systems hit the coastline. So like the jet stream, have y'all heard of the jet stream? Like the thing that brings evaporation from the ocean onto land? Okay, so where the jet stream hits the coast makes rainforest. That's temperate, not tropical, but it's a ton of rain. And that's all you gotta know. Temperate, not tropical, ton of rain. There's a part of Washington that gets more rain than the center of the Amazon rainforest.
Well, like Seattle?
No, south of it. The Olympic Peninsula, the Hoh rainforest, gets like 320 to 360 inches of rain a year. That's more than Manaus, Brazil. Yeah.
I have a quick question about the map.
Okay.
It's kind of like relevant. Can you go back to it? Why are there there's like 2 astrological like oceans?
Cancer
What?
and
Yeah.
Cancer and Capricorn.
Tropic of Cancer, Tropic of Capricorn.
So I don't know why it's an astrology reference, but those are the tropic lines. So 30 degrees north is Cancer and 30 degrees south is Capricorn or something. And I'm guessing that's where you can start to see the constellation year round.
So is that like rainforest there? Or?
Between those two is the equatorial region, the tropics. Back to me. This is a temperate rainforest, extreme rainfall. Extreme rainfall. And you get plant growth that's absurd here. These are conifer trees, but they're giant. If you've ever been to like Oregon and Washington, maybe you know on the coastline, there are some big trees. Now Japan has a few left. New Zealand has a few left. There's some neat species we could talk about, but really what you gotta know is because of these giant conifers, they've been logged. And globally you might have a third, but in the United States, for example, we've used up almost all of it. You might have heard of the Headwaters Forest, like Humboldt University Headwaters, around Mendocino, Humboldt. The headwaters are what's left of these last little bits. It's a pretty small biome, jet stream, coastline. It's a small biome. And here, conifers get giant, so we've mostly cut them down. It's pretty endangered biome. Okay? This is almost nothing. Did your book make you write this down?
No.
then let's just skip it. It's a really small biome, so I'm going to skip it. Hey, check it out. This is where we live. Temperate, like 30 to 60. We're at 34 here. Anybody here speak Espanol? What's a chaparro?
Like you're short.
Yeah, short. Chaparral means short forest. Pygmy trees. You can see it's shrubland, not woodland. Because all of our trees are tiny. Like you've seen coast live oak. It's an oak tree, but it's teeny. And if you look up on the map, it's a cool pattern. They always show up at the exact same place. Look, western side of the continent at 35 degrees. Look, see that red? 35 degrees, 35 degrees, 35 degrees, 35 north, and 35 north on the west side of the continent. You know what's wacky? When I try to talk about our climate, in the last 6 or 7 years, high school kids don't even know what's normal here anymore. Because we've had such weird weather that kids don't really know our seasons. Anybody know how to describe our seasons normally outside of freak weather events? What's our normal weather?
Sunny 70.
We have what?
Sunny and 70.
Sunny and 70 most of the year. What else? Does it rain?
Sometimes.
In winter.
Yeah, we get a little bit of rain in the winter and it hits in big storms, right?
Fog.
3 to 5 storms.
Fog a lot.
Fog is an exception to the rule. There's just a couple spots.
Mesa.
We'll come back to Chaparral. Don't forget your wanted posters and your field trip packets tomorrow.
Do I need you to sign it for third period?
Just write my name.